According to this particular question, we are asked to actually sketch the curve y equal 2x cubed minus 3x squared minus 12x. What the question actually means is to just draw the graph of the equation. In this type of questions, the first thing to do is to actually determine the turning point of the equation that you have. And this is what we mean by the turning point. If you have a sketch like this, what we mean by a turning point is this. So the turning point is the point at which after the thing gets to this point, it turns back and starts moving up. Or if you have something like this, if you have a sketch like this, so this particular sketch has two turning points. It has a turning point at this place and also another turning point at this place. So basically that's what we mean by the turning point. And the trick about finding the turning point is to keep this important point in mind. At the turning point, the slope is actually 0. The slope of the equation is actually equal to 0. This is what we mean by the slope. You would realize that if we pick this particular sketch, as it moves down, which is as it slopes, when it gets to this point, which is the turning point, it becomes 0 before it starts ascending again. If you pick it from this side this way, we go this way, it becomes 0 at the slope. If it ascends, when it gets to the turning point, the slope becomes 0. So what that means is that at the turning point, the slope becomes 0. And what we mean by the slope is the same as the gradient. The slope is also known as the gradient. So at the turning point, the gradient or the slope is actually equal to 0. Interestingly, another term for slope or gradient is the derivative, specifically the first derivative. So keep these key points in mind. So let's first of all find the turning point of the equation. So at the turning point, the slope or the gradient or the first derivative is equal to 0. So let's write the equation of the curve, which is y equal to 2x cubed minus 3x squared minus 12x. So in order to find the turning point, we say the first derivative, which is the y dx, this is how to write the first derivative, is equal to 0. Now what is the first derivative of this equation, which is dy dx? So let's write it this way. The first derivative, which is dy dx, is actually equal to 6x squared. I'll show you how we got that. Minus 6x minus 12. So this is actually the first derivative of this equation. So this is how we got it. So we just pick the exponent of the first term, which is 2x cubed. So the exponent is 3. So we just drop the exponent. We use the exponent to multiply the coefficient of the x cubed, which is 2. So 3 times 2 gives us 6. After we are done with that step, we just subtract 1 from the exponent. So 2 times 3 is 6 and 3 minus 1 is 2. So that gave us this one. So we just repeat the steps for all. So we'll move to the second term. The power here is 2. So 2 times 3 or 2 times negative 3 gives us negative 6. Then we have 2 minus 1 gives us 1. So there's 1 over here. So that's how we got this. There is 1 here. 1 times 12 gives us negative 12. But remember, 1 minus 1 gives us 0. So you have x exponent 0. Remember, any number exponent 0 is 1. So x exponent 0 is 1. And the 1 times 12 still gives us this. So this is actually the first derivative of the curve. And the first derivative is also the same as the slope or the gradient. Now, what did we say about finding the turning point of the curve? At the turning point, we said dy dx is equal to 0. So at the turning point, 6x squared minus 6x minus 12 is equal to 0. Good, so we've really made a significant progress. So the only thing we have to do now is to factorize this, but one interesting thing is we can divide through this equation using 6. So when we divide this by 6, everything using 6, we'll end up getting x squared minus x minus 12 to be equal to 0. So now let's move to our next page to actually solve this. So we transfer this x squared minus x minus 12 equals 0 to find the values for x at the turning point. So this is what we had on our previous page. So let's factorize this. In order to factorize this properly, we look for two factors that when we add them together, we'll get negative x. And when we multiply them together, we're actually going to get negative 2. And those two factors to be positive 1 and negative 2. So we'll use those two factors to replace the negative x. So let's write it out. X squared plus x minus 2x minus 2 equals 0. So we just, after this, we just pull them in, pair them this way, and then factorize each of them in the next step. So this gives us x. We factorize x out. So what are we left in the first bracket? We have x plus 1 in the first bracket. For the second one, we can factorize negative 2 out. When we bring negative 2 out, what are we left with? We are left with x plus 1. Good, equals 0. X plus 1 is equal to 0. So our final answer will be x plus 1 in one bracket and x minus 2 in the next bracket. So we are actually going to take the brackets one after the other to find the value for x. So let's pick the first bracket, which is x plus 1. So if x plus 1 is equal to 0, what that means is that x is equal to negative 1. What if x minus 2 is equal to 0? If x minus 2 is equal to 0, that means x is equal to positive 2. So far we've made significant progress. So we can then come to this conclusion by saying that the values for x are x equal negative 1 or positive 2. So these are the x values for the turning points of the equation. But one interesting thing about every point on a graph is that there is an x component and then also a y component. That is one interesting thing we know about every point on a graph. This is what I mean. If we take a look at this particular graph, this is a point on this graph. In order to arrive at this point on the graph, there is an x component and also a y component that came together to form just this particular point. So if so far we are claiming or saying that we've gotten some values for our x component of the turning point, what that presupposes is that there's also a y component we should look out for. So we found the x components to be negative 1 or 2. So what are their corresponding y components? So that's what we will do. In order to find their corresponding y components, the only thing we have to do is to substitute them into the original equation that we have. So let me write the equation of the curve again. Y equal 2x cubed minus 3x squared minus 12x. So this is what we have as the equation of our curve. So what do? We substitute the values for x to find their corresponding values for y. So f of negative 1. This f of negative 1 simply means the f here is just referring to the curve, the equation of the curve. So we substitute negative 1 into the equation. So write 2. Wherever you say x, we put negative 1 in there. Exponent 3 minus 3 negative 1 exponent 2 minus 12 negative 1. So what does that give us? You see, negative 1 cube gives us negative 1. And negative 1 times positive 2 will give us negative 2. Now let's move to the next one. Negative 1 squared will give us positive 1. Positive 1 times negative 3 will give us negative 3. Negative 12 times negative 1 will give us positive 12. Good. So negative 2 minus 3 plus 12 will give us 7. So our first turning point will be negative 1, positive 7. Good. So when x is negative 1, y is 7. But let's not write that yet. Let's solve for our next turning point. Because remember, I've gotten 2 values for x. So if you've gotten 2 values for x, that means we will get 2 values for y. And that will also mean that we'll have 2 turning points. So f of positive 2. Positive 2 is the next values for x. So wherever we see x, we put 2 over there. So 2 into brackets 2 cube. We are actually still using the same equation. Take note of that. Minus 3 into brackets 2 squared minus 12 bracket opens 2. The cube root of 2 gives us 8. So 2 exponent 3 is 8. 8 times 2 gives us 16. Then we move on to the square of 2 is 4. 4 times positive 4 times negative 3 gives us negative 12. Negative 12 times positive 2 gives us negative 24. Now if you do the math, 16 minus 12, that gives us positive 4. Positive 4 minus negative 24 gives us negative 20. So when x is 2, y is negative 20. So that's what we've gotten so far. Interesting. So what that means is that the turning points are negative 1 and 7, negative 1, 7, and then positive 2, negative 20. So let's write that out. Great job. So far, we've done an excellent job to determine what the turning points are. We can now move on to check the nature of these points to see which of them is actually the minimum point and which of them is the maximum point. In order to do this, we just move ahead to find the second derivative of our curve. When we found our first derivative, this was what we got. When we did the y, the x, we got 6x squared minus 6x minus 12. So that means our second derivative, which will be the y squared divided by the squared x, which is our second derivative, will give us 12x minus 6. We remember the approach we used. 2 drops to multiply the 6, that gives us 12, and 2 minus 1 is 1. There's 1 over here, 1 drops to multiply the 6, that gives us 6, and 1 minus 1 is 0. X exponent 0 is 1. And invisibly, there is x exponent 0 over here. So if the 0 drops to multiply this, that gives us 0. Good. So that's why this one disappeared completely. So the second derivative gives us 12x minus 6. Now what we are going to do is the individual values that we found for the x component. If you remember correctly, we got x to be -1 and +2. We will put these x values into the second derivative to see whether we are going to get positive values or negative values. If you get positive values, what that means is that the value is greater than 0. That means the point is a minimum point. But if you get a negative value, which in other words, saying that the value is less than 0, then that means that point is actually the maximum point. So let's check that out and see. So our values for the x are -1 and +2, right? So let's put them into the equation. So when x is -1, let's try that out. When x equals -1, all that means is that I have 12 -1 minus 6. And 12 times -1 gives us -12 minus 6. That will give us -18. And since -18 is less than 0, that means the point -17 is actually the maximum point. What if x is equal to 2? So far as we've gotten the maximum point to be this, that means the other one is the minimum point. So when x is 2, when x is equal to 2, we input 2 into the second derivative. We have 12 into bracket 2 minus 6. This gives us 24 minus 6. That lands us on 18. And since 18 is greater than 0, that means the point, which is 2, -20, is actually the minimum point. Interesting. So that's how to determine the nature of the point. But there wasn't a need for us to even go through this before we would know which of them is the maximum or which of them is the minimum point. If you check your graph sheet and you check -1, +7, and +2, -20 on the graph sheet, you can actually verify. You will see that this is indeed the minimum point, and this indeed is the maximum point. So now we are done finding which of them is the minimum and which of them is the maximum point. The next thing we are supposed to do according to the question is to actually check the intersections with the axis, both the x-axis and the y-axis. So that's our next assignment. Check the intersections with the x and y-axis. So let's first of all start with finding the intersection with the x and y-axis. When we are referring to the intersection on the x-axis, what it means is where the curve cuts the x-axis, where the curve actually cuts the x-axis. An intersection on the y-axis is where the curve cuts the y-axis. So let me show you that using the graph, this graph. So when we are actually trying to find the intersection on the x and y axis, what that means is where the graph actually touches this x axis. An intersection on the y axis where the graph actually touches the y axis. So it is clear for you to see that when the graph actually touches the x axis, y is indeed 0. So that is an interesting fact to keep. Intersection on the x-axis means that y is equal to 0. An intersection on the y-axis means that x is equal to 0. So we are actually going to apply this knowledge in solving for the intersection on each of these axes. So let's quickly do that and see what we are actually going to get. So let's write this. For intersection on the x-axis, we put y to be equal to 0. So let's revisit our equation of the curve. If you remember correctly, the equation of the curve that we have is actually y equal 2x cubed minus 3x squared minus 12x. So the intercept on the x-axis means that y is equal to 0. So we have 2x cubed minus 3x squared minus 12x. So let's first of all try to factorize x out from this equation. So we bring x out, and what are we left with? We are left with 2x squared, and this side will give us 3x, and now this will be 12. Remember to bring the 0 over here. So after factorizing the x out, we have a 0 equal x bracket opens 2x squared minus 3x minus 12. What that means is that this x here can actually be equal to 0, this 0, or what we have in the bracket, 2x squared minus 3x minus 12 can also be equal to 0. Why do we make that assertion? Because we are saying that there are two values. The first value is x, and the second value is what is in the bracket. If either of them is 0, it makes the whole thing equal to 0. So let's take the first assumption. If this x is 0, 0 times what we have in this bracket will give us 0. Okay, the other assertion. Let's assume this x is a huge number. But if everything we have in this bracket evaluates to 0, it will still make this equation 0. So that's why we said this x can be 0, or what we have in the bracket here can be 0. So let's move on to the next step. So we found the first intercept, which is 0. So keep that in mind. The first intercept is 0, and this is the next intercept. But we have to actually find the roots of this particular equation to find the values of the x. So let's transfer this equation to our next page. In order to find the root of this quadratic equation, we'll be using this formula, which is x equal negative b plus or minus square root of b squared minus 4ac, all divided by 2a. Let's make some few points over here. From this particular equation, the coefficient here, which is 2, stands for a. So a is equal to 2, and b is equal to this value here, negative 3, and c is equal to this, negative 12. So we just substitute those values into the general formula. What is the value for b? The value for b is negative 3. So negative, remember there's already minus over here. So negative into bracket b. b is already negative 3. Plus or minus square root of b squared. b is negative 3 all squared minus 4 ac. a is positive 2 and c is negative 12. This divided by 2a, and a is 2. So negative times negative 3 gives us positive 3, plus or minus. What do we have in the brackets? The square root of negative 3 gives us positive 9. Negative 4 times 2 gives us negative 8. Negative 8 times 24. Negative 8 times 24 will give us positive 96. So you have positive 96, all divided by 4. Finally, we are going to get x equals 3 plus or minus square root of 105, all divided by 4. So the next step is to just use your calculator and pick 3 plus. You first work with the positive, so you know we have plus or minus. So you just key everything you have here into your calculator, but the first try just use positive. So that will be 3 plus square root of 105 all divided by 4. After that, you do 3 minus square root of 105 all divided by 4. After doing that, you are going to get two values for x, and the value should be 3.3 and then negative 1.8. These are the values you are going to get. Good. So at this point, we are done calculating for our intercept on the x-axis. So let's write that out. So our intercept on the x-axis. So far our intercept on the x-axis are negative 1.8, 0, and 3.3. Here are our intercept on the x-axis. If you've forgotten how we got the 0, refresh your memory. Remember this one. Remember this particular value, the 0 here. This is one of the intercepts. So the intercepts on the x-axis are actually negative 1.8, 0, and 3.3. What about our intercept on the y-axis? For our intercept on the y-axis, x is equal to 0. Remember, this is the equation of our curve. Remember, this curve, this is the equation. So for our intercept on the y-axis, x is equal to 0. But from the look of this particular equation, if you put 0 here, 0 here, 0 here, 0 here, that will mean y is equal to 0. So for this particular curve, the intercept on the y-axis is actually 0. So let's not go through the pain of solving that. The intercept on y-axis is actually 0. Now let's write our turning points again, which are negative 17 and 2, negative 20. Before we proceed with our plotting, because these are the values we are actually going to use. Now let's move to our graph. So write this value somewhere and follow us as we plot our points. So let's first identify where our turning points are. So this is negative 1, 7, this is 5, 6, 7. So negative 1, 7 is going to be somewhere here. This is our first turning point. And our next turning point is 2, negative 20. So positive 2, negative 20 is going to be somewhere here. Good. Now what about our intercepts? For our intercepts on the x-axis, we have 0. Remember, we got 0 somewhere. We had 0. 0 is part. And we also have negative 1.8. So here is 1. Negative 1.8 is this. It's going to be somewhere here. And then our 3.3 will be 3.3 will be somewhere here. Good. And our intercept on the y-axis is also 0. So it's going to be at the same point. So now let's try to sketch this curve. This curve is actually going to be something like this. So our curve is actually going to be something like this. This is not a perfect drawing, but I think it gets the job done and it helps you to understand the steps involving curve sketching.